All right, let's take a look at lesson 143, volumes of prisms and cylinders. So we're going to use kind of what we talked about in the last lesson where we looked at the classifying 3D figures. We're going to be looking at finding the volume of these figures. Now, this formula for the rectangular prism or cubes is length times width times height. Now this is also, and you're going to see in this formula here in a minute, volume is equal to the area of the base times the height. Okay, where B stands for area of the base, H is the height of the prism. But in a rectangular prism, it's easier to think about it as this, because then you don't have to determine which one's your base. You just have to multiply your three sides together. So let's look here and practice this. We're going to use volume is equal to length times width times height. So it doesn't really matter which one you call your length, width, and height. You're just going to multiply all three together. So we're going to do 9 times 17 times 24. Now, as we calculate this answer, we're going to get 3,672. And our units because we're multiplying centimeters times centimeters times centimeters, we get centimeters cubed. So volume is always measured in cubic units. So the units are always going to be cubed. So in number 2, we're going to have cubic inches, and number 3, we're going to have cubic feet. So once again, get in the habit of writing down your formulas, even though that you may not know exactly how to work it. It's good to get in the habit of this. That way you always know which formula you're using. So if you make a mistake, you can go back and look to see where you did something wrong. So now we're going to have 10 times 14 times 4.5, and that's going to give us 630. This will be cubic inches. And number 3, volume is equal to length times width times height. And once again, it doesn't matter which one you call what. We're going to multiply 39 times 12 times 8. And our volume here is going to be 3,744. This will be cubic feet. All right, so that's the first part, just rectangular prisms. So just use this formula when you're only dealing with rectangular prisms. Now all other prisms have the formula where we have the area of the base, which we talked about the bases, the ones that are parallel, faces that are parallel to each other. Okay, that's how we know which one's our base. And that capital B stands for the area of the base, which means you may have a different formula. You may have to use different formulas for whatever your base is. It's not going to be the same formula every time. So for triangle, you're going to use 1/2 base times height, which is not the same as this and not the same as this height. Okay, so we have the height of the prism, which is the distance between our parallel faces. So if this right here is the other base, it is the distance between these two parallel faces. That's the height of the prism. Now, it could be a rectangular, it could be a trapezoid. You'd have to use the trapezoidal formula. It all depends on what the base is what formula you use. So let's look here. In this problem here, we have a triangular prism. So we know the volume formula is going to be area of the base times the height. So let's identify the height first, because the base usually requires more work. So let's see, the height of our prism is the distance between. Now, once again, if you need to highlight your faces, you can do that. This is going to be one of our faces here on the top. Okay. And our other faces on the bottom. Okay. So these are our two faces here. So I'll kind of erase this bottom part so we can kind of see what we're talking about here. Now the distance between this, okay, the distance between the two bases is this right here. This becomes your height. So your height here is 5 feet. Okay, that's how far it is between the top triangular face and the bottom triangular face. So now to find the area of the base, well, we're going to use the formula 1/2 base times height, but this base and height has nothing to do with the height of the prism. This is the height of the triangle. So now we're going to look at just the triangle here with the dimensions given. So I'm going to kind of outline this so you can kind of see what we're looking at. There's our triangle. Okay, so if this is 12 up here, that means this is 12 down here as well. Okay, if this is 10 up here, that means this side is 10 down here. Now the height they give us, the dotted line, remember we look for the height that's perpendicular to our base. That is our height for this. This is going to be 1/2 our base of 12 times our height of 7.3. So this will be a calculation all on its own. So this will be 6 times 7.3. And when we multiply that together, we're going to get 43.8. So the area of the base is 43.8. So now to find our volume, we're just going to go back and plug in 43.8 times 5, the height of the prism, and our volume is going to become 219. This will be cubic feet. Okay, so let's look at the next one now. Another triangular prism. So notice that this is the base here. Okay, this is the face, this triangular face. And so we want to know, let's identify our information. Volume is equal to area of the base times the height. Our height is the distance between. So this is going to be the height. How far is it between my front face and the back face? That's going to be 16. The area of the base, once again, is a triangle, so it's 1/2 base times height. So 1/2 of my base, which in this case is 11 on the front triangle, and the height is 5.4. So as you multiply this together, you're going to get the base is going to be 29.7. That's 1/2 times 11 times 5.4. So to find our volume here, we're going to do 29.7 times 16. And that gives me that my volume is equal to 475.2, and this will be cubic millimeters. All right, this next one here, number 6. In this problem, notice we have two sides that are parallel with the front and back here, and those are trapezoids, which means we're going to have to use the trapezoid formula to find the area of our base. So volume is equal to area of the base times the height. Okay, the height in this problem is easiest to find. That's the one, the distance here. That is 25. That's how far apart is the front and the back. Now the area of the base, remember this is going to be 1/2 times the height plus times base 1 plus base 2. So let's plug our numbers in. We got 1/2. Our height of our trapezoid is this right here. That's going to be 17.9. Our two bases are 14, which we get from here, and 36, because that 36 goes there as well, so 14 plus 36. So we're going to calculate the area of the base, so just plug all that in. That's going to give us 447.5. So now to find the volume, we're going to take the 447.5 and we're going to multiply it by our height of 25. And that gives us a volume of 11,187.5. This will be cubic meters. All right, so remember the area of the base is going to, the formula we use for the area of the base is going to change based on what the base is, what shape that base is. So let's look at the next one here. So in 7 and 8, we may have to do a little work here. So let's look to see what we have here. This is going to be a triangular prism. Okay, so we're going to have volume is equal to area of the base times the height. The height here is the distance between, which is 31. This is the distance between here, so that's between my two triangle faces. Now this is a right angle here because it's a right angle over here. So the area of the base is a triangle, 1/2 base times height. Now, in this case here, we're going to have 1/2. My base, I don't have down here. I don't know what it is. I don't know what my base is. My height, I know, is going to be 28. The height of this triangle. So now, how do I find my base? Well, I know this is 32.5, so this is 32.5 over here. So what we have is we have two sides of a right triangle, so we're going to use Pythagorean theorem to find our base. So base squared plus 28 squared equals the hypotenuse squared, 32.5 squared. Now, we're going to plug all these numbers in, and this is going to be we're going to subtract 28 squared from the other side here, so b squared is equal to 32.5 squared minus 28 squared, and you have to square them first, and then we're going to take the square root. So in our calculator, our base is equal to, we can plug this in, we're going to do, I'll show you here. So let's clear that. We're going to take our number, we're going to have the square root of, and we said it was going to be 32.5 squared minus the 28 squared, and that gives us 16.5. And it already does the square root, so our length of our base is going to be 16.5. Now, once you understand the Pythagorean theorem, you can always you can do a little shorter without having to write everything out because you know exactly what you're supposed to subtract. But remember, you always have to square it first before you can subtract it. So our base is going to be 16.5, so that comes in over here, 16.5. And now we can calculate this area of the base, which is going to give us 231 as our area of the base. So now volume is equal to 231 times 31. And that's going to give us a volume of 7,161. This will be kilometers or kilometers cubed. All right, so let's look at the next one now. This one can be a little trickier. Okay, notice we have a trapezoid here. Okay, so let's look here. We got the volume is equal to the area of the base times the height. So let's identify the height of the prism. So how far apart are these two trapezoid faces? Okay, that is going to be the 35, so that's my height. So now I need to find the area of the base, which we know is 1/2 times the height of the prism. So we don't have that. This is the height right here. Height over here. We don't have that distance. So we're going to have to find it. Our two bases are going to be 25 plus 39.4. So we've got to figure out what is that height. So once again, we're going to come over here and make a triangle because we know how to solve a right triangle if we know certain parts. So I know this side here is 30.6. So this right here I need to know from here to here. Well, I know the full distance is 39.4, and I know this distance is 25. So this is 25 here. So if I take 39.4 and I subtract 25, okay, that is going to give me this distance right here, which is going to be 14.4. So this distance here is 14.4. So now we have two sides of a right triangle, so we can find the third. So this is going to be our height. So height squared plus 14.4 squared is equal to 30.6 squared. So let's let our calculator do the work. So we just need to make sure we set it up right. So we're going to subtract the 14.4 squared over from both sides. H squared is equal to this difference, so it's going to be, and then we're going to take the square root. So 30.6 squared minus 14.4 squared. This just saves you from having to write all the decimals. So once again, we'll take our calculator. And we're going to have the square root of 30.6 squared minus, because it's always the hypotenuse minus the other side, 14.4 squared. And that gives us 27. So it comes out to be a perfect square, 27. So we go back over here, and our height is now 27. So we can go back and plug it in over here. So now, area of the base is going to be 1/2 times 27 times the sum of these, 25 plus 34. And that is going to give us area of the base being 869.4. So volume is equal to 869.4 times the height of the prism, which is 35. Multiply that out, and that gives us a volume of 30,429 point, oh, no point here. Oops, wrong eraser here. And it's going to be centimeters cubed. Okay, so we had to do a little work there, nothing too difficult. Okay, you're going to use Pythagorean theorem most of the time when you have to do some of these. All right, let's take a look at cylinders now. Cylinders, I think that whenever we work with cylinders or something has a base of a circle, it just becomes easier. So the cylinders formula is the area of the base, which is pi r squared, times the height of the prism. Okay, so once again, it's the area of the base. Same thing as volume is equal area of the base times the height. But this case, in a cylinder, it's always going to be pi r squared. So we can just memorize this formula, where r is our radius and h is the height of the prism. So let's look at this. Once again, volume, we're going to write down our formula, which is going to be pi r squared h. So our radius in this problem is going to be 18, and our height is equal to 15. So volume is equal to 18 squared times 15 pi. So your homework may say leave this in terms of pi, which means you're not going to calculate it. We're first just going to put in 18 squared times 15. Okay? And that's going to give us 4,860. And we're going to just bring down the pi here, and this would be cubic inches. So that's one answer. That's exact answer. Nothing's rounded off. We've got in terms of pi here. So now, the next answer is if we take and we multiply by pi. So we take 4860 and times pi, and that's going to give us a decimal, which will go to 2 decimal places, and that'll give us 15,268.14, and once again, cubic inches. So if your problem says leave it in terms of pi, then you do it like this first one. If they say round to a certain decimal place, that means you're going to calculate pi, and you're going to leave it like this. All right, let's look here. Number 10, we have a cylinder again, and we have, we need to write our formula down. Volume is equal to pi r squared h. So our height here is going to be the distance between the circle bases, which is 21. And our radius here, well, they give us a radius of 11. So that gives us the diameter of 11. Sorry, diameter is equal to 2 times the radius. So they gave me the diameter, which is 11. So to find my radius, I'm going to divide by 2. And so half of 11 is 5.5. So there's my radius. So volume is equal to 5.5 squared times 21, and then we're going to attach a pi. So as we calculate this value here, okay, that's going to give us 635.25 pi. And that would be our first answer. That would be in meters cubed. Second answer is when we multiply by pi, so that gives us an answer of 1,995.70, and this would be meters cubed. So 2 chances here when you have 2 answers. One is exact in terms of pi, and one is a rounded off or close estimate because we are rounding. All right, so let's take a look at 11. We have 2 problems left in application type problems. So it says a cylinder with a 2 centimeter diameter is drilled through a triangular prism shown to the left. Find the volume of the prism. So let's look at the formulas we're going to use. We're going to use the volume of the, or kind of how we're going to approach it. We're going to take the volume of the triangular prism here, okay, triangle, and we're going to subtract out the volume of the cylinder. And that's how we're going to approach this problem. So we need to find the volume of the triangle first, okay, which we know the volume of a triangle is going to be found by taking the area of the base times the height. So the height of this is going to be 14. That's how far it is between the triangular faces, or bases here. So then the area of the base is going to be found by doing 1/2 base times height. So in this case here, it's going to be 1/2. And notice this is this little right angle right here in the corner. That means that our base and our height are both the same, so it's 5 times 5. So the area of the base is going to be 25 divided by 2, which is 12.5. So the volume is going to be 12.5 times 14. So the volume for this is going to be 175, and this will be in cubic centimeters. So now we're going to have to subtract out the volume of the cylinder. So the volume of the cylinder, as we know, it is pi r squared times the height. So the radius and the height are only 2 variables we have to identify. The radius in this, they said it's a 2 centimeter diameter. So if the diameter is 2, that means our radius is 1 because you cut it in half. And the height here is still the same because the height of the cylinder is also the height of the prism, which is 14. So volume is going to equal 1 squared times 14 in pi. So just for purposes here, I'm going to leave this in terms of pi for a second until I go back and calculate. So the volume is equal to 14, or excuse me, entire volume is equal to 175 minus 14 pi. And we'll plug this in our calculator, and that'll give us 131.02 cubic centimeters. And now we go to our last problem. So it says, a diagram of Eric's pool is shown to the left. He plans to fill the pool to a depth of 4 feet. So it's 4.5 feet tall, and he's only going to go to 4 feet. So this means he's going to be going to about a level right here, all the way around. So this part right here is going to be filled with water. So he's going to fill it with a garden hose that takes approximately 80, or it says 80 cubic feet per hour flow rate. So how many hours is it going to take? So what we need to do is we need to find the volume of the pool at this height of 4. We're not doing it all the way to the top, we're only going 4. So let's identify what we're going to use here. This is a cylinder, so we're going to take the volume of a cylinder formula, which is going to be pi times the radius squared times the height. Our radius is going to be half of 27 because 27 is the diameter. So that's going to be 13.5. And our height is going to be 4. So volume is equal to 4 squared times the height of 13.5. And it's going to be times pi. So this is going to give us, I'm sorry, I wrote the wrong numbers here. Let's go back and change this here. The height is 4. We're going to square 13.5. So we're going to square the radius, multiply it by 4, and then multiply by 5, or pi. So this is going to give us 729 pi. Okay, so I'm not going to calculate this yet because I still have a little work to do. So I don't want to round off anything yet. So this becomes my volume. Now what we're going to do is we're going to figure out how long is it going to take for him to fill it up. If it goes, the hose will fill it up at 80 cubic feet per hour. So what we're going to do is we're going to take 729 pi and we're going to divide it by 80. So let's go over here, calculator, and we're going to do 729, and we're going to put pi divided by that 80. And that gives us 28.62 hours. So, or 63 hours. So it's going to take him approximately 28.63 hours to fill up that pool. All right, so that concludes our lesson on the volume of prisms and cylinders.